for the invitation to be here with this high-level panel to discussing the issues and questions on safety of tailing dams. And it's a pleasure to be here and appreciate very much this discussion. First, before I go to my point, I would like to refer to a mention of Professor André Assis that our profession specialized in tailing dams is being in a stage of intense revision of procedures because of the impact of two main failures in the last years. That was Mount Poly in Canada in 2014 and Fundão from Samarco in 2015. Both failures caused big impact on that because at that stage the profession was working with several rules and procedures of good practice that was understood at that time that is okay. Every procedures are recognized, good procedures and so on. But suddenly, two important dams got to fail, and every people asked why. We have discussed today in another section the surprise that the dams that fails give for the engineers. It is very important, this stage that is in a revision of procedures. In several aspects of this revision are still very controversial, and some of the concepts are in the edge of knowledge. Discussions on adequate safety factor and conditions that we may apply on drainage strength analysis or drainage strength analysis is being discussed with not a common sense of adequacy. So this is a good opportunity to make a review of several procedures. The point I have chosen to discuss here is related to risk management and risk management system that is in the core of the management system today, looking to the risks and treat all the parameters in order to minimize that risks. This is the main concept, but the risk management requires that all relevant parameters related to risks are very well understood, because we have to act on these parameters during the operation of the dams to minimize the risks. And even we need to monitor the parameters related to risk to understand better what's the performance of the dam. Frequently, we need to ask, are we listing the dam? Are we knowing what the dam is saying to us about its integrity? Then the monitoring system have to go into that questions and give you answers. A good monitoring plan is essential to obtain information to feed analysis of the performance and the risk management system. It is like the doctor that to prevent a risk of a heart attack, monitor your blood chemical, your veins, if it's clogged or not. You have to go into your body and list your body. What is saying for you, for the doctor, what are the risks? The dam is the same thing. The dam is a live body. It's not finished when it's finished the construction. We have to pay attention to that. So we have to think in terms of the monitoring plan, in terms of a risk approach. That's the way I would like to discuss the monitoring plan here. We are working in I-Code Committee on Tailings Dams, starting to write a monitoring bulletin. I-Code have already issued a bulletin on monitoring before, but this is concentrated on details of the instruments, how it's manufactured, how is the technique to install, to read, and so on. And we have proposed for this committee now that the new bulletin starts from a conceptual basis that what to measure, what to monitor. The lack of answers to the question like what to monitor, where to monitor, which instrument to be used, can result only in spread out instruments in the dam. It is frequent that when we go to make an assessment of the safety of a dam, to have readings of instrument that we don't know why that instrument is that on certain position. We need to give a sense of utility for each instrument that we put in the plate, so we can acquire a continuous knowledge of behavior of the dam in a level of details to make and simulate different conditions and evaluate the probability of failure and the risk evaluation. Because we can make probabilistic approach on the analysis based on hypotheses and on parameters, but we have to check in each position we are in relation to the risks situation of the dam. Based on these evaluations, the action plan for safety management can be prepared, and the managing the several actions. The gathering of the data of the performance of the dam, so is an essential stage of risk analysis. Based on these needs, the monitoring plan should involve the several activities to be a good plan. The proposal is to make the main steps, including first, proceeding risk analysis, characterizing the failure modes, its effects, consequence, and probability of occurrence. If you go through all the failure modes and have a good definition how to measure properties and the situation that give the risks, we can improve our risk management. Based on a risk analysis, we can find for each failure mode which parameters we have to monitor to know the status of the failure mode in the monitoring control. For instance, we can use an expedite way would be the failure modes and effect analysis. We can use probabilistic too, but the failure mode is FMEA is more straightforward and give a good idea of the several failure modes and its risks and consequences. So we can make, for instance, this is a spreadsheet of FMEA. I didn't put this in order that you can read, because it's difficult to read this long and large table. It's just to give an idea what the FMEA proceeds in that. The first failure mode is A1. You assume that if you have a weak foundation, that can give a slope failure. A weak foundation can give a slide, and releasing discharging the water and the tailings to downstream. how to observe that, how to measure that. Then we can indicate that we have to put piezometers there on the weak layer. We have to put inclinometers. We have to put benchmarks and so on. Accordingly, we go through all the possible failure modes. We have to make an effort to cover all the possibilities. The doctor Hartford give a good lecture today saying that despite the fact that we go through all the possibilities, there are some of them that were unexpected, that combine to fail the dam. So it's not easy, it's not an easy task to make a good risk analysis. You have to combine failure modes that are unlikely, apparently unlikely to occur, but then can give the reason for failure in that. If you proceed like that and go into all the possibilities, we at the end achieve a risk matrix like that FMEA plots the failure modes in a way that we can see in the risk matrix the combination of probability, likelihood, and the consequence. The points that are on the more tends to red are the points that combine more likelihood combined with bad consequence, worst consequence. So this gives also a priority indication of what we should observe first. What you should observe if you have problem of budget, for instance, you leave the blue region and go to the red area in order that you make it. What is the difference in the normal or routine monitoring plan is that in this plan we are choice the main questions that give risks and put the instruments when you receive the readings and analyzing the results of the performance. You can relate it to risk analysis and make a better quantification of what is the situation of the risk position. So, concluding the remarks on that proposal is that the risk analysis previously to the planning of the monitoring system permit to identify clearly the relevant parameters to be monitored. The considerations on the failure modes can give a rational approach to the monitoring and for the managing of several risks. This makes possible also to establish the priorities to be given for the instrumentation. And the outcomes of the results of the instrumentation plan shall fit the risk assessment of them and the risk management plan. This is the way we propose that the risk analysis can be linked with the monitoring system in order that both can give information together to make a better evaluation of the risks. This is the point I would like to put.
Thank you, Jose, to bring this idea, settling towards a better contribution for safety structures for tailings. I ask Christine now for your presentation.